Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Shadi Eldib from Tabarak Private Schools. How are you, my students? I hope you'll be fine. Welcome back again in a video related to before last topic in this or before last topic in chapter 3 in our syllabus. Today we need to talk about the wave-particle duality. We'll explain today the wave-particle duality. What's meant by this? We'll explain everything and who discovered this duality. Everything related to this part we'll explain it today in this video. Firstly, what's meant by wave-particle duality? Wave-particle duality, this discovered by what? I'll tell you. In 1924, Einstein wrote, there are therefore now two theories of light, both indivisible and without any logical connection. What's this? Who discovered this wave-particle duality? One of the famous four, his name is De Broglie. De Broglie, and we'll explain it. He's a Frenchman, De Broglie, okay, and we'll know what's this De Broglie said. Now, what's meant by duality? Duality means double or couple. Couple of what? If you have light, and as we know that light consists of photon. Okay. De Broglie discovered what? This photon that the light consists of, it has two behaviors. Number one, wave behavior, and number two, particle behavior. Again, wave-particle duality. What's meant by wave-particle duality of light? Wave-particle duality of light means that the light consists of photons, as we know before from Einstein. This photon, or any particle like electrons also, it has two behaviors. Number one, wave behavior when it moves, and number two, particle behavior when it moves. So, light, for general, it has two behaviors, so we can say now wave-particle duality of light. It means light has two in one. Two in one means wave and particle properties in one thing's photon. Okay, how can we know, or what is the evidence for wave nature of light? The evidence of wave nature of light is diffraction and interference. If you wanted to check this light or this photon, it has a wave behavior, it means it has diffraction or interference. But if it has particle nature, like what? Like photoelectric effect and Compton effect. Compton effect and photoelectric effect. Photoelectric effect in our course, but Compton effect not in our course, but you have to know it generally. Extra information. So this is the evidence. So the evidence of wave nature of light is diffraction and interference, but the evidence of particle nature of light is photoelectric effect. Okay. Now, how can we know? What's the equation that it combines the particle wave and particle wave equation? Okay, again, what is the equation that De Broglie discovered that combine the wave behavior and the particle behavior? This equation. Lambda equals h over mv. Lambda equals h over mv. What's h? H is Planck's constant. We know it before. And mv, linear momentum of particle. You know momentum? Momentum equals mass times velocity. And what's lambda? Wavelength of the particle. Look at this equation. This equation now combine between wave properties, wave behavior, and particle behavior. Where is the particle behavior? mv. Any particle has momentum. So mv is the particle property, particle behavior. And where is the wave behavior? Lambda. Lambda is the wave behavior. So he said what? He said, De Broglie, that particles could behave like waves under certain conditions and therefore have a wavelength and be subject to have phenomena, to wave phenomena like diffraction. And he formulated this equation later, proving correct by effects like electron diffraction, photon diffraction. Lambda equals h over mv. Now let's talk about this by using some of the examples. De Broglie equation. He said determine the wavelength of an electron. It has a mass 9.1 times 10 power negative 31 kilogram, moving at, this is velocity, 5.31 times 10 power 6 meter per second. Compare this to the wavelength of passpole moving with the same speed. Okay, now we need to find out the wavelength of electron. Electrons lambda equals h over mv. As we know, lambda equals h over mv. And h is the Planck constant, 6.63 times 10 power negative 34 joule second. This is constant. And mass of this 9.11, because here in decimal 9.109, so it will be 9.11 times 10 power negative 31 kilogram times 5.31 times 10 power 6, this is the speed. You will find that the wavelength equals 1.37 times 10 power negative 10. Pay attention, the relation between lambda and the momentum mv inversely proportional. Don't forget this. It means, or the lambda and the mass also, it means inversely proportional. If you have proton or electron, you will find its mass very small mass. So the wavelength, very huge wavelength. So we can observe electron, but electron wavelength. But for ball, a ball has a huge, not huge mass, but we can say huge mass as a comparing with electron. It's a huge mass comparing by electron. So m, huge mass. Then lambda, how can we find it? We'll find that lambda, it's inversely with m. So if the mass of the ball is huge, a huge mass as a compared with the electron, so wavelength is very, very, very small for the ball, so we can't observe it. Because the relation between lambda and mass, it's inversely proportional. Extra question. Calculate the mass of a photon with wavelength 3.6 A. What's A? Angstrom. Angstrom, one unit, we can use it for wavelength instead of meter. But we have to convert angstrom to meter. How? Lambda equal 3.6 angstrom, so it will be 3.6 times 10 power negative 10. To convert angstrom to meter, 10 power negative 10. So he said calculate mass. Okay, from the formula, lambda equal h over mv, so m equal h over lambda v. Where is v? He didn't give it to me. No, you know it. Where? Because the mass of, the velocity of the photon equals the velocity of light, because light consists of photons. So c, the speed of photon, the speed of light, 3 times 10 power 8, already given, and we know it. And direct substitution, m, get it as a subject, equals h over lambda v. So h equals 6.626 times 10 power negative 34 divided by lambda, 3.6 times 10 power negative 10, multiply or times 3 times 10 power 8. So now we get the mass of the photon, 6.135 times 10 power negative 29 kilogram. All of you understood? I hope that, and I hope that you train about this. And this is the topic, last topic before the last topic, sorry, in this chapter. Welcome, and I hope to be fine, and I'll see you soon inshallah next video talking about a new topic in our chapter. Thank you and goodbye.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education, and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in Model in the website of our school.